Welcome to the RP2350 prototyping with Raspberry Pi Pico 2 and the CELUS Design Platform. My name is Luís Ferreira. I'm a customer success engineer here at CELUS. And with me, I have José Ginjo helping me in the chat, answering any questions that you might have over here. I hope everybody is having a good day. Before we start, you should be seeing a poll in your screen right now. I ask you to answer it and to give us your answers into that pool. It's really appreciated. So, getting started. For today's agenda, we are going to talk about the Raspberry Pi Pico 2 development board. We are going to create a project using that development board. I'm going to show you in a live session how to use the CELUS Design Platform to create that same project, and how to leverage the power of CELUS Design Platform to get a quick prototype using less time than you typically would have while creating a prototype and to develop all of the necessary files. In the end, I will make a recap about it and a QA session. But please make your questions as we go if you have any using the QA panel. Before we start, I would like to know how many of you are already registered in our platform. Please raise your hands if you have already registered. And if you haven't, you can go to app.celus.io, click sign up, and follow the registration steps. I can see a lot of hands up, so it's a good thing. A lot of people have already registered. For those who haven't, please go to app.celus.io and register to follow up with the things that we are going to do in this webinar. Moving forward, I will also like to ask you to speak up. If you have any feedbacks, any questions, please use the chat and the QA panel to do it, or just wait for the QA session in the end of this session to present your questions. I will be happy to answer it, or Ginjo will also be supporting me on the panel to answer the questions from the chat. So please do leave your questions and feedback. We really appreciate it. Getting started. What is the Raspberry Pi Pico 2 development board? What's inside it and why is it important? Well, the Raspberry Pi Pico 2 development board is a microcontroller board, just like Pico 1, just like any other Raspberry Pi development board. But this one is built around the RP2350 new high-performance, low-cost MCU that Raspberry has just released. Instead of using the RP2040, which was the previous version of that microcontroller, Raspberry Pico 2 delivers a significant power boost comparing to the older version of the Pico board. This is because of the new RP2350 microcontroller, which features a higher clock speed, more memory, more cores, more powerful cores, different types of cores. So in this microchip, you can actually have two types of cores, an ARM core and a RISC-V core, which means that you can change the core that you're using depending on the task that you are actually working on. And the good thing about it, the best thing about it is actually that it's really cheap. It costs only $5. So you can build your own prototype, a high-performance board, keep it cheap while not compromising the performance, because you can still have a high-performance MCU with a low price. What's inside this development board? Of course, we have the Raspberry Pi microchip, the RP2350 in the middle. That is, of course, needed, but the board also has other components that are needed to work with the RP2350. For example, an USB for power and communication, a DC-DC converter to generate the 3.3 volts needed for the microcontroller, right? Instead of 5 volts, you use the DC-DC converter to convert it to 3.3 volts. We have a flash memory to store, program, and user data. You have a tactile button to, in this case, for boot and user interfacing, and a LED to signal the program operation of the system. And more importantly, you also have an input-output header that will enable you to connect other things to this development board. But, of course, this alone doesn't help you do anything. You need more things around it to actually be able to create a project using this development board. So what you need is to add some sensors, some actuators, a communication, for example, or some kind of another button, a display, whatever you need to create a human-machine interface communication. You can add, for example, Wi-Fi or Bluetooth. You can create temperature sensors and pressure sensors to read the environment, and you can, for example, add some motors to actuate upon the environment, of course. And by having the board in the middle and adding these external components, you can create a new device, a new prototype to create your system in a really quick way. Shortly, I will show you how to create this same system. So using the development board and external components, how to create it using the CELUS Design Platform, and how to fast forward the creation of that system. That's exactly what I'm going to show you right now on this live session. But first, I would like for you to answer the poll that is going to show on your screen right now about how did you join this webinar and why. We would really like to know where did you learn about us, and please fill it up. Moving forward, if you go to app.celus.io, as I told you before, you should be seeing this sign-in page. And at this sign-in page, you can use your email address and password that you already created. And if you haven't, please sign up and follow the registration steps and come back here and sign in for you to be able to use our platform. Once you sign in, you should be able to see this front page where you can see your name, welcoming screen with the create new project button, some articles for you to explore. You can also see on the bottom your recent projects. In this case, I have created 2 projects. But if you scroll down, more importantly, you'll actually see the feature projects. And what are the feature projects? Feature projects are reference designs that are ready to use. They will help you jumpstart the project creation. So instead of creating the project from scratch and having to add all of the components by yourself, you can use an already created project and just add the things that are missing. So it will create faster development of your project without losing so much time. As you can see, we have a first project, my first project, which is a basic project. And in the second place, we have an RP2350 minimum viable board. And this is the one that you want. It's a project that already has the minimum things needed to work with an RP2350 microcontroller. You can either copy the project or you can view the project. If you copy the project, it goes directly into your recent projects and you can start editing the project. In this case, we are going to click View Project for us to check the project before copying it to make sure that this is what we really want. And as you click View Project, you can see that you have different blocks already connected. You have a USB connector, a power supply connector, a microcontroller. So it's basically the same circuit blocks that compose the RP2350 Pico 2 microcontroller board. And you also have connections between them. You have a supply connecting USB connector to the linear DC-DC conversion. You have a USB communication between the USB connector and the microcontroller, of course. And all of the connections are already defined over here. You can also notice that some blue dots are on these squares. What this means is that below these blocks, a solution is already there. And if you right-click it and click on View Cubos, you can see solutions, and cubos are the solutions for each of those blocks. So as you can see, this is a regulator that has an input and an output as required for the project specifications, and you have different solutions over here that you can select. But right now, since we are in a view mode only of the project, we cannot, and you can check that by going onto the top right corner. You can see that you're on read only. You cannot make any change. To make the changes, you would need to actually copy the project and start working on it. And to do that, I'm going to click on the copy button. And as I do that, you will see that something changed. I now have a design library on the left where I can have more blocks to add to the system. In this case, since I want to create a board not only with the minimum components of the RP2350, but as I said before, I actually want some other components in here, I'm going to start adding components. And to do that, in the left, you can see that you have a search bar that you can use to search for blocks, for functional blocks, but you also have recommendations. Recommendations it's the way our AI assistant has to tell you which blocks does he feels that are important for you next. So what can you add to this board to work with to create your system? And as you can see, it's suggesting wireless communications, which in fact is actually something I actually want, because as I said before, I want to add more features to the board. And in this case, I want to add wireless communication. To do that, I can just click on it, drag and drop it to the canvas, and there you go. Now you have a wireless communication block. I can also add some sensors, and as you can see, it's already suggesting me a temperature sensor, and I'm going with the suggestion again, so I'm just going to drag, drop it, and add a temperature sensor. I also want a flash memory because the main board, the RP2350, has a flash memory, but this one doesn't. So what I'm going to do, since it's not suggesting me a flash memory, I'm going to go to the search block and click and start writing flash. And as you can see, below the recommendations, you see a flash block. I'm going to do the same thing, drag and drop, and now I have a flash board. I will start to connect these things now because we now have the functional blocks, but no connections between them. So I want the wireless communication to be connected to the microcontroller. So I'm going to click on the microcontroller, click on these plus buttons that you can see, and by clicking them, I'm going to create an extra connection point. I'm going to do the same thing on the wireless communication side. Click on the plus, and there you go. Now you have two communication points. How do you connect them together? Well, you hover the dot that you just created, and as you can see, the arrow changed. You click, you drag it, and you release it on the next connection point. And now you are connected the microcontroller with the wireless communication block. But you still need to define which type of interface. So to do that, you right-click on the interface, click Manage Settings, and as you can see, a new panel shows up where you can select the interface over here. You can click it, you can see the different interfaces that are available, and in this case, I want it to communicate using UART communication. So I'm going to start tapping UART, and you can see UART over here. I'm going to click it. I will also click on this show label link because I want these labels to appear for me to be easier to read which port is connecting these two blocks. I'm going to click Apply Updates. And as you can see, now I have a UART connecting the wireless communication with the microcontroller. I need to do the same thing for the temperature and the flash. So I'm going to add two more ports. I'm going to add it below because I don't have any more space over here. So I'm going to add two more ports over here and two ports, one in the temperature sensor, another in the flash, and I'm going to connect it. Drag and drop them from dot to dot. They're connected now. I just need to define the communication interface that I'm going to use. So then again, manage settings. And in this case, I'm going to use I2C to communicate with the temperature sensor. So I'm going to write I2C, show label link, apply updates. There it is. Same thing for flash, but since it's a flash, I want a quicker, a faster communication protocol. So I'm going to do it with what SPI, since it's typically used to flash interface. And I'm going to do the same thing, apply updates. Now, all of these blocks are connected to the microcontroller, but they still, as you can see from the others, they're still missing a supply because we want them to be powered. So what I'm going to do is I'm going to connect them to the same supply as the microcontroller and the tactile buttons. To do that, I'm going to, again, to create connections points on each of this side, on the other side, of course, because it's easier to connect on this side. Now, to connect them, as you can see, if I drag and drop them, I cannot connect them to the line. This is an existent link, and I cannot do it. To connect to an existent link, what you have to do is click on the link, and you see this arrow over here. You click the arrow, you drag it, and you connect it. And now you have a connection. You can drag the connection to put it in a better place for reading. And now you just do the same thing for the other two. You click on the connection link, you see the arrow, you drag and you drop the arrow. Repeat again for the last one. And there you go. Now they all have the minimum necessary connections for it. You can see that I have the power, I have the UART, I have the I2C, the SPI, everything is connected. Now, as you can see, no blue dots are over here. And if I right click, I cannot select my Kubo. I cannot select the solution. This is because I haven't resolved yet. I haven't asked the system to find solutions for me. So what you can do is that you need to click resolve on the top left corner and the system will try to find solutions, meaning kubos, that fulfill not only the function that you're asking for, but also the connection between functional blocks. I can see there is a question from Kiran. Are there any plans to allow CELUS to integrate with Cadence, Allegro, or PCB-CAD? That's a good question. There are. Our plan is to actually start to support as many CAD tools as we want. Right now, we just support Eagle, Altium, and KiCad, but in the future, we plan to support much more CAD tools and try to support as many as the industry uses. So, as you can see, I click Resolve, it finished the resolve, and now the blue dots are appearing in all of my kubos, all of my blocks, all of my functional blocks. This means that a kubo was found, at least one kubo was found for each of these blocks. And if you right-click it now, you can actually select a kubo. And if I'm going to microcontroller, I can see that I have now over here the RP2350 that I talked about. I can see the different microcontrollers, that there are actually 4 versions of the RP2350, and I can see them over here. I'm going to select one of them. How can I select one of them? Well, you can either just check the schematic, or you can actually open the kubo. You can click over here on this information button, and you'll be redirected to this page where you see more information of the kubo. You see the specifications, you see the bill of materials, you see the additional resources, and you also see the ports that are available on this on this microcontroller. You can see the different ports. You can open them and see the specifications of those ports as well. You can actually click on signal to net mapping and see the connections. So the signal to net mapping that is occurring on the kubo. So which nets are connected to which ports. You can just click and go back. And for example, let's say that I selected that I want to use this kubo. What I can do is click on this select button. And as I click it, it will ask me to lock or to select it. If I click lock, it means don't change this no matter what, and this kubo will keep selected no matter what the requirements are. The platform will still try to use this kubo as better as it can. Going back to design canvas, I can select other things. For example, using the flash, I can go to the flash again, and I can see different flashes. If I don't want to open each kubo and see the difference between them, in the bottom right corner, you can see an assistant, a Kubot assistant. You can click on it, and you get a chat. And you can ask as many questions in this chat as you want. You can ask, for example, what is the memory size of Kubo 1, for example. It will take a bit, but the memory size is 32 megabits. So this memory has 32 megabits inside. You can use Kubo to ask any questions that you like, and you can even see that when it refers the Kubo, it has a link on it, and you can directly click and go directly to the page of the Kubo. And as you can see here, it has actually the 32 megabits inside. But you can make more complex questions. You can ask them to compare to Kubo, say, hey, give me a suggestion of a Kubo. You can do all of that. For example, a good example that I like to do is on USB connector. You can actually ask for, well, there are too many USB connectors. I have a specific USB connector that I want to use. I want a 2.0 USB protocol, and I want ME suppression. So what I'm going to do is asking to Kubo to recommend me one solution. So just going to do recommend a Kubo that uses USB C 2.0 and as EMI suppression. I see another question. How Kubo selects components, Major, DigiKey, or which companies are preferred? So right now the components are being built, these Kubos are being built by our team. So we select the components, and later on there can be, we use IHS to select alternatives for these Kubos. And as you can see, it recommended this Kubo, the 6297, blah, 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 horizontal connection. And if I click it, I can see it is a 2.0 USB-C, and it effectively has the EMI suppression, and it actually has more than that. It also has the ESD protection. So as you can see, the Kubo is not just the component, it's actually the circuit around the component to enable the user to use the component without adding extra circuitry, because the circuitry it's already there. So assuming that I have selected all the things that I wanted, I have selected my flash, I've selected my temperature sensor, my wireless communication sensor, everything that I need, and all of them has a blue dot on them. The only thing that I need to do now is click resolve once more. And when I click resolve again, what will happen is the bumper view and an output file will be generated out of the selections that you just made. So you selected the Kubos that you want, the pieces of circuit that you want, and now you want to export it to a CAD tool. And that's what the resolve button will do right now. As soon as the resolve stage is finished, you can see a bumper view where you see the functional blocks, and inside each functional block you can see the Kubo that you selected and the bill of materials for the Kubos, and you can even click and go to the component page of that component, and you even have datasheet information that you can read directly over here without having to search for the component, all in one place. If you move forward, you have output files. On output files, you see a PDF, which is a basic documentation of the system that captures everything that you selected so far. And you also have a project package that you can select using Altim, Eagle, or KiCad. In this case, we are going to go with KiCad. What you get from this project package, and while it's downloading, I already have one downloaded over here. What you get from it is the full schematic. So everything that you selected, every schematic that you selected before, you can see them directly on KiCad ready to work. All of the components, all of the Kubos that you've selected, you get them here. Not only the schematic, but even better, you also get the footprints and the preliminary layout already ready for you. So all you have to do right now is finish some routing. Of course, check up, make sure that everything makes sense again. You're still the responsible to make sure that the connections are okay. It's still up to you to make sure that the system is functional and makes sense. But you can get from an architecture design from an architecture design with just an idea to a specific board with CAD files ready to work with just a matter of seconds. And if you're not happy with it, no problem. All you have to do is go back to Design Canvas, change whatever you think you need to change, make extra connections, add extra components, generate again, and there you go. You have a different design. With just a few clicks, you can generate as many designs as you can. And summing up, that is basically the value of our platform is that you can capture the development board, add additional components to it, evaluate the different solutions, make sure that the solutions are good and make sense, and then you can extract those files and hand them out to any CAD tool that you prefer to, without losing as many time as you do right now, that you need to read the data sheets, download CAD files from different sources, compile everything together, add it to the CAD to the EDA tool library, and prepare all of that. It's already prepared, and you can jumpstart the creation of your prototype really quick.